Prefabrication is the practice of assembling components of a structure in a factory or other manufacturing site and transporting complete assemblies or sub-assemblies to the construction site where the structure is to be located. There are several main advantages of prefabricated constructions: accelerated build schedules, consistent quality, financial savings, and environmental benefits. Principal guides for design of prefabricated modular objects. For such projects, a lot depends on the right choice of material and construction opportunities. We should define the specification of kit of parts and elaborate possible variety of architectural parameters. After it, we finally define the joining principle and structural configurations. The most important limitations for prefabricated objects are transportation limits. There are maximum dimensions of commercial vehicles in the European Union, and here is a table of different types of trucks. There is a large number of options for prefabricated construction elements. A project-specific requirement will determine the choice of modular system. In general, 2D elements call for more assembly on-site, 3D volumetric units are more fully fitted out off-site. For our presentation, we have chosen three main typologies of modular buildings: framework constructions, panelized constructions, modular cell constructions. Framework constructions consist mainly from linear module elements and connectors. As an example of this type, we take the Klima pavilion. It's half-spherical temporary pavilion. The framework constitutes a geodesic dome and made of aluminum rods connected through a plug-in system. The geodesic domes have their own special advantages, such as extremely high load-bearing abilities, but also the typical disadvantages of such type of prefabricated systems: large number of different connection joints. The industrial sphere-shaped connector was used in case of Klima pavilion. Often connectors should be developed by architect individually, according to load-bearing requirements and assembly convenience. The second common type is a panel modularization. As an example, we have chosen multiply pavilion. It's temporary pavilion, made entirely from CLT. The multiply structure itself appears to be a simple set of stacked boxes and look typical for this type of prefabrication. Multiply pavilion was designed with tongue and groove joinery connecting members in order to optimize the speed of assembly and disassembly. The third type of prefabricated modules is modular cells. The whole building consists of several almost completed blocks. We have chosen Wicker House as a great example of this type of prefabrication. It consists of the segment created by wrapping 24 layers of high-quality cardboard around a central mold. Each module weighs 500 kilos and is finished with a waterproof coating and wood paneling. The connection of two modules provided by a bolted connection with threaded rods. It takes only a day to set up the whole house. The Wiki House project demonstrates new approach to prefabrication. Client gets a file with plywood details layouts, prepared for local digital CNC fabrication, and a detailed instruction for assembly. The components can be rapidly assembled like a large flat pack by any able-bodied person, even without traditional construction skills. This example is notable by two reasons. Construction of WikiHouse structures requires no special parts because the cut pieces of wood snap together with wedge and peg connections. Thus, the project strategy determines the type of details. This project used the benefits of digital revolution. We can set up digital microfactories for a fraction of the cost, a network of local manufacturers sharing common solution using the web. It's called Industry 4.0. Modern technologies are affecting the design, fabrication, and assembly methods of prefabricated buildings. Digital fabrication is a workflow where digital data directly drives manufacturing equipment to form various part geometries. It allows to deal with the conceptions of the modularization and prefabrication in new ways. A project, the Programmed Wall 2006, was a part of a research course at ETH Zurich. Students designed a brick wall to be fabricated by an industrial robot. Unlike a mason, the robot has the ability to position each individual brick in a different way without extra effort. Anyway, the wall itself stayed within the assembly logic of brick material. At the Venice Biennale 2008 was exposed the Blobwall Pavilion by Greg Lynn. It was an innovative redefinition of the brick into a lightweight object made of colorful plastic and reinterpreted into modular elements. The idea behind this pavilion is an attempt to rethink the very definition of the module. The project Cyberphysical Macromaterials by ETH students, Stuttgart University 2016, demonstrates a vision of kinetic prefabricated architecture for public spaces. Both constructed module and the very builder autonomous aerial vehicle were customly prefabricated. Modules are constructed from lightweight carbon fiber filament with integrated electronics, which operate alongside a collection of drones. The system challenges ideas of robotic digital fabrication and sophisticated prefabrication for architecture. The new pavilion Steampunk for 2019 Berlin Architecture Biennale by Soom and Ham was created using analog tools with the precision of mixed reality environments. The installation explores an adaptive design and fabrication system that's resilient to wide tolerances in material behavior and fabrication accuracy. AR instructions for such projects create an opportunity to use low-skilled workers to prepare and install constructions of such complexity. Today, architects and designers continue to explore how prefabrication can change the world. The digital and industrial revolutions have reawakened the possibilities. As we've seen from the selection of the examples, the prefabricated industry is accelerating and increasing speed. At the same time, both production methods and the construct of aesthetics are rapidly changing. With further technological innovations, the concept of prefabrication is laying the groundwork for the future of building.